Vincent Boks, Managing Director EMEA Water Division, NSF, discusses the recently introduced NSF P524 water quality testing devices for drinking water protocol and the NSF Guideline 533, ingredients used in drinking water products. He also explains the crucial work that the organization carries out in terms of testing and approval of materials, systems and chemicals for water treatment solutions, with greywater recycling technology an increasingly important focus.
Okay, so the start, it would be good to understand a little bit about NSF, the organisation, a bit of background, when formed, why, and any sort of key milestones to date.
Yeah, so NSF was founded in 1944 with a mission to improve and protect human health and planet health. And our mission is carried out by almost 3,000 employees around the world, including microbiologists, toxicologists, chemists, etc. And manufacturers, regulators, and consumers look to us to develop public health standards and certify to these standards to help protect water, food, consumer products, and the environment. And in the water sector itself, we test and certify all types of products that come in contact with drinking water, going from plumbing products to treatment chemicals, from filters and disinfection devices to plastic pipes and fittings. Important to add is that NSF is also a World Health Organization collaborating center on water quality as well as food safety and indoor environment. And our headquarters are based in Ann Arbor, Michigan, United States, and in EMEA, our main offices and labs are in the UK, offices in the UK as well as in England and in Wales, as well as Belgium, Germany, the UAE, South Africa, etc.
Okay, and in terms of recent activity, I believe you launched, and I'll read this one out, NSF P524 water quality testing devices. So it'd be good to understand a little bit about why those are introduced and what are their the main features, functions.
Yeah, that's correct. We developed so far over 100 public health standards, of which around 25 are in the drinking water area. And these standards have been developed to address specific public health concerns, as well as to focus on new technologies. And recently, we developed the NSF Protocol 524 to test and certify water quality testing devices. Interesting is that this is the first ever protocol that provides a standard third-party validation of the performance of water quality testing devices, in short, WQTD, used in drinking water, ensuring public health protection by providing assurance that these critical devices, these crucial devices, perform according to the manufacturer's claims. And the new protocol has been developed through a collaboration between NSF's leading experts and industry experts, including manufacturers, public health officials. Until now, manufacturers of these WQTDs could only advertise performance claims based on their own validation testing. So now they have the opportunity to validate these claims by a third party. And these devices, we talk about sensors, for instance. At least now manufacturers can claim the accuracy and the precision of the device through a third party. And why is it important? Because as we all know, access to clean and safe drinking water is a fundamental right, and it's essential that we have the reliable tools to measure the safety of the water supply. And the launch of the NSF P524 protocol for these quality test devices is a significant step forward in ensuring users have access to accurate information about the safety of their drinking water. And the protocol, having the protocol available for these devices used in the drinking water, helps provide confidence to utilities, but also to other users, that these products are suitable for use in our water systems. In short, the protocol will help provide another layer of protection for the safety of our drinking water.
And just as a matter of interest, when it comes to the idea for the protocol, was it your organization that thought this would be a good idea to come up with this so that there is a standard for people to work towards? Or did some of the manufacturers of these devices come to you and say, I won't say they're fed up with people making false claims, but say we need a standard to which people can, how does that, how do you come about the protocol? Where does it come from?
Yeah, very often it's a mutual process between NSF as a standard developer, between manufacturers, between regulators, etc. So often within the wider industry, there is a need for regularization, for standardization, and this is when NSF gets involved.
Okay, and I know you've been busy because I think it was in my inbox this morning. I got the announcement that you've also launched NSF Guideline 533. So that's pretty hot off the press. So can you talk us through what that one is?
Yeah, exactly. So it's very hot from the press indeed. So the NSF Guideline 523 focuses on ingredients used in drinking water products. So the guideline covers ingredients, but also resins, master batches, processing aids, impact modifiers, everything that is part of a formulation, whether it's of a plastic material, a rubber material, etc. And before it was only possible to certify an actual product or a full formulation against an NSF standard. But today it's also possible to certify specific ingredients. Again, examples are PVC, polyethylene, polypropylene materials, for which then we can certify the ingredients. And with this new certification, manufacturers of ingredients used in drinking water can have the ability to certify the ingredient itself, which will then help them to promote the safety, but also to promote the ingredient themselves to producers of the final compounders of the O-rings, of the pipes, etc.
Okay, and just to clarify that and the standards you use protocols, they're global, are they, in reach? Because as you say, with the ingredients for drinking water, for example, I know there'll be a lot of variations from country to country and continent to continent, but what you're doing is covering that whole spectrum, shall we say, of the different varieties across the world.
Yeah. So the regulatory landscape on ingredients, but also on all products and materials in contact with drinking water is rather complex and organized per region or country. So if we look at the NSF standards and protocols, they have originally been developed for the North American market, USA and Canada. First standards, well, we have NSF 14 that was developed in the 60s, but other standards in the 80s, etc., developed mainly for North America. But during the years, we've seen that these NSF standards have been adopted in other parts in the world, being the Middle East region, where we have Saudi Arabia, United Arab Emirates, and other GCC countries who have officially adopted NSF standards in their local codes, plumbing codes, etc. But also South Africa, Israel, some parts in Asia, some parts in Latin America as well. If we look at UK and Western Europe, let's say, drinking water material standards are organized per country. So there are other standards in place. In the UK, it's mainly the BS 6920, part of the RAS requirements, where NSF is also heavily involved with. So we have tested for more than 20 years now against the requirements of RAS. And recently, I'm talking a couple of years, NSF developed the NSF Rec 4 certification scheme, which proves that products and materials in contact with drinking water comply with the regulation 4 of the water supply, water fittings regulations in the UK. And it's a very interesting topic, because there used to be only one way to show compliance to this regulation 4, which was the RAS approval, which led that a lot of specifiers, architects, consultants in the UK still believe that RAS is the way, or the only way to show compliance, where there is also NSF Reg 4, which is a complete and in fact a faster and more straightforward way to gain certification of water products and materials to sell in the UK.
Okay, and in just sort of in a bit more general terms, the main focus of the organisation is looking at, I guess, testing and approval of material systems and even the chemicals that are related to the drinking water process. So, I mean, you've outlined some of the things you do, but can you give us a flavour, if you like, of just what that involves on it? It sounds like that's quite a large workload to undertake. So what tasks do you typically undertake, if that's possible to explain?
Yeah, definitely. So at NSF, specifically in the water division, we test and certify all types of products that come in contact with drinking water. And I will just go aside. So you see here the whole water distribution net. So it's all products going from source to tap, products and materials going from source to tap, starting with the water reservoirs at the municipal water treatment place, where coatings that are used in the water reservoirs need to be NSF certified to show that the coatings do not contaminate, do not migrate any of their contaminants, ingredients into the water. The water then follows the pipes, valves, pumps, etc. in the municipal water distribution network. Also, these products are certified by NSF on the health effect side. We then have the water meter inside the boundary of the house, O-rings, taps, plastic pipes. So all products that distribute water until it flows out of the tap are certified by NSF, and the main standard to do this is NSF ANSI 61, developed in the 80s. Today it's NSF ANSI CAN 61. And if we then look at the chemicals themselves, we have a specific standard dedicated to test and certify water treatment chemicals. And when we talk about water treatment chemicals, it's about coagulants, flocculants, disinfectants, but also reverse osmosis, antiscalants or well drilling aids. These products are tested and certified to NSF 60 to verify that when the chemical is added into the drinking water, that the chemical does not harm the human being when the water is being consumed. So important to note is that it's a health effect standard. So we want to check to verify what the effect is the chemical has on the drinking water and eventually on the human being. But we don't focus on the performance, the treatment performance of the chemical.
Okay, so I mean, that's a fairly large undertaking you've outlined, but I'm wondering as well, do you get involved on the wastewater side, and or there are a lot of industrial water users, which are, I guess, has a slightly different focus as well? So are those areas you play in at all, or is it just the drinking water side you do, or others as well?
Yep. Thanks for asking that question. So on the wastewater treatment side first, we are involved, and we developed several standards to certify wastewater treatment systems, but it's really the residential focus. So we are not talking about municipal wastewater treatment. Why residential? Because and it's mainly for areas where residential treatment systems are installed because the houses are not connected to the municipal water sewage system. So the household itself is treating their own wastewater to then discharge in the nature. And standardization certification for these residential systems is important because these systems are managed, are maintained by households themselves and not by professional water engineers. So we want to make sure that the quality of the products of the systems is at the right level when consumers buy these products. And then more recently, we are also involved with certification of greywater reuse systems. Greywater from showers, from washing machines. And this has become obviously more and more important because this greywater, when it's treated, it can then be reused for gardening, toilet flushing, etc. And if we talk about the industrial applications or the wider applications, NSF is less involved from a certification perspective. However, we see that often pumps, piping systems, valves, etc., that are used in industrial applications are very often already certified for drinking water end use. If, of course, the type of application, the type of industrial application demands that high quality. But for industries, apart from the certification aspect, we do assist manufacturers reviewing their water management, their consumption, and to work together with them to reduce that.
Okay, and you mentioned the greywater side, so that we're talking sort of environmental sustainability angles. And I'm just wondering as well, does your remit cover, for example, use of chemicals to treat water? It's clearly important, but there is beginning to be, shall we say, a pushback, and there are other ways of treating water. Mm-hmm. Do you get at all involved in those kind of debates, or are you literally there to, when someone says this is what we want to do, and you give it your approval or not, or whatever, to a certain protocol, or say, do you encourage debate and lead people in certain directions? What is your remit, I guess, around that and that type of activity?
Yeah. So firstly, it's important to note that NSF is an independent organization. So we work together, and I think I mentioned it during one of the previous questions. We work together with regulators, but also with the industry and consumers. But this said, we are independent. So if we look at or listen to your question, it's often in the regulatory area where certain chemicals are restricted or forbidden. And as a result, NSF updates our standards if this input comes from the regulatory scenery. But in general, we are not the driving force behind eliminating or restricting chemicals. On the sustainability aspect itself, I confirm it's a very, very important topic to all companies, but also to NSF. And today, when we look at sustainability services within NSF, we do focus, for instance, on life cycle analysis of products. We focus on flow rate testing of taps, of showers, etc. And on the greywater reuse system certification that I just mentioned. And if I'm focusing on the water reuse systems, the topic, I mean, it's booming. It's becoming more and more important because, unfortunately, freshwater scarcity is a growing international concern. Today, around 4 billion people, nearly 2/3 of the water population, experiences severe water scarcity during at least 1 month of the year. And looking at 40%, I mean, it's a lot, of the population, of the world population, will be living in seriously water-stressed areas within the next 10 years, or at least by 2035. And therefore, we believe that the NSF ANSI 350, a standard that was developed in 2011, is very important with the established, the clear, rigid, and realistic guidelines for these on-site greywater treatment systems. It does not only increases the quality, but it also creates greater awareness and education on the public for this water reuse aspect. Climate change and population growth is exhausting freshwater supplies faster than we can adapt, and we feel that this NSF 350 standard is certainly supporting that aspect.
And it would be good to understand as well a little bit how you work with customers. So you produce these protocols, but when it comes to approvals, somebody submits, I guess, is it a component or a system for you to evaluate and then approve or not? But do you work with them as well to tell them how they might gain approval, or do you literally say, no, this doesn't meet the approval, come back when you're ready? Or is it an interactive thing, so you help them work towards a solution that's going to meet whatever particular protocol they're working towards?
Well, there are two aspects, in fact, to this question. So the first one, and I like the question, and I think it's good for manufacturers and the wider industry to understand this. We talk about third-party certification. So an organization like NSF, we test and certify products or materials, and in order to test and certify, we need to first of all gain information about the product or material, but we also conduct a production facility audit. So we do an actual visit to the production facility. And the process, of course, we work together with manufacturers to guide them through the process, but NSF remains completely independent on advising how they could potentially pass the test, or how they could develop or improve their products or formulation to pass the test. So we are here to test and to verify, but we are not here to consult manufacturers, producers on how to pass the test. And we are quite rigid in it. We do have our accreditation bodies in various countries, North America, UK. In UK, we are accredited by UCAS. That makes sure we stay completely independent. But on the other side, this is the second part of my answer. There is already a lot of information publicly available. And what I mean with that is mainly the NSF listing, where you find all products or materials that today are already certified to NSF Reg 4 for the UK, certified to NSF 61 for against the North American standard. And one obvious advice we give to companies who are in process to gain certification is, well, if we take an example of a water meter or a pump, if you want to gain certification on that water meter, well, the water meter is going to consist of a plastic material, of some sealing materials, rubber materials, etc. When you source for your materials, we always advise to source for already NSF certified materials, because if you, as a water meter manufacturer, source a certified NSF 61 certified O-ring, you're confident that that O-ring is safe to be in contact with drinking water. Otherwise, it would not be certified. So that's an advice we can give, because this information is publicly available. Another example is for water treatment devices, filters, disinfection systems, etc. The NSF listing specifies exactly for what that product is certified. Every treatment device that meets the NSF standards is tested against specific performance claims, and it's up to the manufacturer to point out which performance claims they want to focus on. One example is if you want to certify to NSF 42 a carbon filter, you could select, for instance, the claim of chlorine reduction, taste and odor reduction. But as a manufacturer, you could also say, I'm not that much interested in the aesthetic claims. I want to focus on health-related claims. So I want to test my product for lead reduction or PFOS reduction, or even going a step further to NSF 401, where you want to focus on bisphenol A or ibuprofen, or I mean, there are plenty of claims where manufacturers select between being test against that, and then the NSF public listing gives a lot of information to other manufacturers or to end users who want to or are potentially interested to buy the products.
Okay, and maybe just one thing before we finish. You mentioned grey water recycling a couple of times, and that's a newer technology. So whereas the water quality testing has been around for a long time, so I guess it's relatively easy to produce a protocol based on what people are doing. But when there's a new technology, is there any sort of template that you might have as to at what stage you decide the technology is mature enough that it needs a standard for everyone to work to? Because when everyone's starting out, they're all doing different things. So at what point, or just to understand how something evolves to the level where you think it's time to put a standard together for people to work towards?
Yeah, good question. So it's again a combination of NSF being involved with regulators, with manufacturers, etc. And in most cases, the technologies are driven by the manufacturers, by innovative companies. And from a certification, standard development and certification perspective, our goal is to make sure we protect public health, we protect end users, but we are not here to stop innovation or to stop manufacturers. On the contrary, we want to support new innovation, to support manufacturers selling their products, but we want to make sure it's happening in a safe way. And I think this is where certification comes in. Today, even more than in the past, people expect to have very fast product delivery from their suppliers. Today, you buy something online. If we stick to the filter example, you buy something online and you expect it to arrive at your home the next day. So manufacturers are under a huge pressure to manufacture faster, to ship faster, etc. And in this environment, certification has become even more important, because there is not only fast delivery, but also delivery across shipments across the world. And third-party certification makes sure that the quality and the safety remains. And this is where it's important for end users or for the wider industry to look at the certification aspect. Then coming back to your question about, is there a specific process? Not necessarily. What I mean with that is that often it's manufacturers who contact us to see if we have already an available standard to test their product against. And it's at that time that we realize, okay, because of this specific innovation, there is no available standard, but we're going to work together with that manufacturer to understand, okay, what's the technology, what's the innovation, how can we measure this from a testing perspective, from a standard development perspective. And we're then working together with that manufacturer, with regulators, to come up with a protocol or with a standard. It doesn't mean that for every single innovation, we develop a new protocol. There should also be a market need for it. If it's a very specific product that the industry itself claims that it's that unique that there are not going to be other manufacturers going into that direction, there is probably no need for standardization. I mean, if it's only unique, there is no standardization need. But then, as soon as there is a standard development in place, I mentioned it's together with the manufacturer who came up with this innovation. but we have specific, and this is certainly defined, specific defined processes where we involve the right stakeholders to come up with a standard or protocol. Why is it important? NSF, I mentioned at the one of the previous questions, we developed over 100 public health standards. We don't do this in isolation. We do this with selected stakeholders, and also the maintenance of the standard is done through what we call joint committees that are regularly meeting to make sure that existing standards continue to meet the market requirements, specific innovations, etc. But it's done together with the industry, together with regulators, together with end users.
Okay, and a final one, I promise, because you've given me a lot of your time, for which I'm very grateful. But in terms of what we might expect from NSF, are you able to share any of the work that's, if you like, on the drawing board at the moment and will lead to protocols or some standards in the future, and just a flavor of what's currently in your inbox, if you like?
So we already touched base on two of them, very recent developments at the NSF 533 for the ingredient certification, and NSF P524 for the water quality testing device. So this has been recently developed. In the meantime, we're also looking closely at the chemicals and treatment of them. For instance, the PFAS aspect has recently become a part of our standard NSF 53. So we're now able to test and certify water treatment devices specifically for these reduction claims. And I think then the last area that is definitely worth mentioning is what is happening in Europe on the regulatory aspects, because during the next years, different European or member state standards will be harmonized, and it's going to be very interesting how this will be translated in what the applicable standards will be. And of course, it's a very good development, because manufacturers in the UK, in Germany, in France, or wherever, who want to sell into different European countries often have to undergo different tests, different certification processes. And NSF today, we're involved with that. So we do support companies with the Rec 4, NSF Rec 4 and RAS for the UK, but also ACS for France, KTW for Germany. But it's going to be a very good development for Europe to have a harmonized standard, and NSF being present in Europe since the 1980s will also be part of this and be there for local European, but also outside of Europe manufacturers who are interested to sell their products into Europe.
Okay, well, Vincent, you've given me a lot of your time, and I'm really grateful for it. I enjoyed the conversation, so thank you very much indeed. Thank you.
Thank you.